Ware. I'm from Freedom, the other side of the valley, not Spring City, but somehow I got involved and it's been a great thing. And so I guess Ken Law came out and looked at a home I'm building and squealed on me and asked if I would come and talk about some construction techniques that are possibly, in my opinion, better than what most people are doing. So tonight we're going to talk about energy efficient construction, and you've all got a handout. And so I want to start with just a little bit about history. Shelter was either found or man-made since the beginning of time. And it was always quite energy efficient. If you think about a cave, does it get really, really hot or does it get really, really cold? Neither, it stays about the same. And as man moved around and as man did all sorts of different things, they started doing adobe. They were building their own bricks or their own rocks or that. And then they used sod and things of that nature. And if you go to Europe, you look that they've got buildings in Europe that are hundreds of years old, and they're all made out of big stones, heavy rocks, things like that. And the answer to what makes them more energy efficient is thermal mass. And if thermal mass doesn't make sense to you, it heats up and it holds the heat. The larger the rock, the larger the stone, the larger the natural battery is, if you will, is it takes a temperature and holds it. So if you want it to be cool, cool the stone, cool the rock, and it will stay cooler longer than, say, a 2x4. And so that's really the answer as to why in Europe they have less need for heating than we have here, because the European heating is localized in the smaller areas they live in, but it heats the entire structure and it holds the heat. So current day, for some reason, the United States of America was smarter, and we decided to go cut down a bunch of trees and make log homes in the beginning, which are quite energy efficient because you have anywhere from 6 to 8 to 10 to 12 inches of wood, which acts as the insulator. And the reason we have R values in insulation is it equates to inches of wood. Yes, sir?
In my experience with a log cabin, I built one just north of here, 10 miles, that is in Skyline Mountain Resort. And we would come on a weekend, not every weekend, and I'd leave the furnace down about 45 degrees. So we'd come and turn the furnace on, put fire in the fireplace, and it would take all weekend to get those logs up to temperature for us to go away and let them cool off. It was not efficient for that style of living.
It's an insulator.
Yes.
Wood is an insulator. It's not thermal mass. It doesn't absorb heat and hold it. And so I agree, it insulates fairly well, but it doesn't take the heat and hold the heat.
Right.
So that is one reason that log cabins are...
They're great for year-round living.
Yeah. So that's the difference. I mean, why is it less energy efficient, stick frame, wood frame? Because you have no thermal mass. Okay? And in the pictures, I've got some pictures of back here. Some adobe, which were very efficient. Got a picture of stick frame. And if you look at the stick frame, you're probably all familiar with typical construction methods. Your wood is the insulator and you have a whole bunch of holes. So
that's the definition of a window.
Yeah. Yes, between every 2x4, it's a window. Yeah. And so once you do that, now you have a structure that you have to then go back and fill all of the space between the 2x4s or 2x6s, which are the only insulation. And so which we're trying to get back to the wood. We're trying to do what a log cabin does. And so that's my problem with stick framing. Okay, so there's a photograph of that. And so we'll look at some of the innovations that we've got to go along with that. Is once you get your 2x4s and 2x6s up, then you cover them with a wood sheeting. It used to be plywood, used to be 1x6, now it's OSB, which is oriented strand board, and that is how you give that pile of 2x4s some kind of rigidity, so it doesn't just lean over, fall down. It keeps the major wind from blowing through, things of that nature. On top of that, you add house wrap, which is a breathable material that prevents wind from blowing through and theoretically lets humidity out. Okay, so all we're trying to do is get back to a solid wall with lots and lots of pieces. Then you add your finish inside and out, sheetrock, and you tape all that. Now you're trying to seal the inside, and now you're putting your stucco, your stone, your wood, your vinyl, your whatever on the outside, and now you're trying to protect the outside and keep the air from moving in and out. If you live in an older home and you haven't met the energy code, if you take the cover off an outlet and it's windy outside, 9 times out of 10, you can feel a draft blowing through that outlet, which means you're not very energy efficient at all because the house is not very tight, and so you're getting lots of air coming in and lots of heat going out, or cool going out in the summertime, either way. So some of the innovations that we've had over the past 10, 15, 20 years. Insulation has come a long, long way. We've got rigid foam, which is similar to this, okay, which on the outside of a lot of homes, they will stick 1 to 2 inches of foam outside of the house wrap, outside of the OSB, and then put the covering that's pretty on the outside of that. That gives you extra insulation. It's about R7 per inch, and air can't blow through the foam as long as you seal the joints. So that helps. You've got spray foam, which I don't know if everybody's seen it, but that is one of the miracles of the latest century or latest 10 or 15 years, is that with the spray foam, you can go back and you seal small cracks, large cracks, around any of your outlets, those sorts of things, and that's one way to boost your energy efficiency. Roll foam. Several different kinds available. This one is commonly known as a double bubble. And it has these little bubbles, little round things there, that are filled with air. And that becomes an insulator. The other benefit is on both sides, you have a reflective material. So you've only got the air as the insulator, but now you have reflectivity, or a radiant barrier. You can pass that around. The one I prefer, because I'm not a fan of the bubbles, not sure that that air is going to stay in the bubbles, is a reflective material with a closed cell foam. The closed cell foam will not lose air, it will not change, it is not attacked by insects or rodents or anything like that. This piece of material right here has an effective R value of R17 in 5 millimeters. The same company makes one that's twice that thick, and it has an effective R value of R23 in 10 millimeters. Those are huge advances. The other advance that I really like is a Mylar film. This particular one is perforated. The advantage to these 3 materials is the reflectivity. If you've ever been to a home show and they've got an aquarium and they've got a heat lamp on one side of it and they've got a thermometer on the other side and they're showing you the difference in temperature, these will reflect 99.9% of the heat. So if you insulate and you reflect, you are putting 99% of the heat back in and keeping the insulation doing its insulating job, and you're really boosting your insulation. These can be used in new construction or remodels. Yes?
How large, are they come in sheets or rolls or?
These come in 22.5-inch rolls, so you could put them in your attic. They come in 4-foot wide rolls, anywhere from 300 to 1,000 feet long. And it's not incredibly expensive. This is relatively cheap, and this can be bought on Amazon, Temu, Verver, however you say it, wherever you like them. And this is really, really inexpensive. A 300-foot roll is about $150.
What are they called? What would you search for?
This is Radiant Barrier, or Mylar. The brand name is Prodex, and it was originally designed for metal buildings. Where if you build a metal building and you want insulation, used to be you would drape a roll of fiberglass over it and let it hang and hope it didn't get wet, hope the birds didn't eat it, and things like that. This came out, and this actually gives you the R17, where a 2 to 3 inch, maybe 4-inch bat doesn't get you anywhere near that and doesn't have the reflectivity. And so that has now come into the typical construction market, and I've used each one of these in my home. Roll foam, safe foam, bubble, Radiant Mylar. One of my favorite innovations is insulated concrete forms. What this does is this gets us back to the sod house, the adobe house, all those sorts of things. Most of us have basements or have had homes with basements and concrete walls in the basement. This particular method takes the concrete all the way to the roof. You don't need any additional forms. You can stack them like Legos. You add rebar. And the really cool thing is, it snaps in place. You don't have to tie it like normal. You do tie it on the joints, you do tie it in the corners, but it holds the rebar. So you're effectively building a full concrete wall with 2.5 inches of insulation on each side. So you're gaining your thermal mass, which once you heat it, once you cool it, holds the heat or holds the cool, and it's insulated from the outside and the inside. This particular method of construction with a 6-inch concrete core takes roughly 48 hours to transmit heat through it. So if you heat your house to 70 degrees and you're waiting to see how fast the heat moves, it will take about 48 hours for that heat to move through that wall. As opposed to a 2x6 wall with an R19 fiberglass insulation or blown-in insulation in the wall, that starts to transfer heat in about 2 to 2.5 hours. And it doesn't have a concrete core, it doesn't have a thermal mass heat bank sitting inside there. These are, in my opinion, the way to go in the future. We're not using a whole bunch of trees. It's the cost of these stays pretty constant. During the COVID shutdown, concrete didn't vary more than a couple of dollars a yard. OSB went from about $9 a sheet to about $65 a sheet. I saved money by doing this because I didn't buy OSB at $65 a sheet. I paid concrete price that didn't vary more than a couple of dollars a yard. Okay, so those are some really big things that I've seen. Otherwise, before we were talking, Ken was talking about gunite, shotcrete.
I had a question. What is the foam made out of? What material is it?
This one is a version of styrofoam,
Which is
petrochemicals of some sort that they mix together, and it's in the little beads. They blow it in there and it sets up.
So how hard to get those chemicals? Where do they come from and how? Is there an unending supply of that, I guess is what I'm asking.
We have plenty of oil for the petrochemicals to do that. And so, again, anything can come into short supply for any reason. But even during COVID, there was no supply chain on this. These are US made. There's about a dozen different versions. They don't interchange, but there has been plenty of source available, and it has not been an issue. Ken was talking about another version. This one is a solid wall. There are some others out there which you have basically a grid of concrete and you have foam in the middle. I prefer a solid concrete wall. I don't think it's gonna go anywhere. I think it's more safe, it's more secure. I like the thermal mass. Ken did a basement out of, what was it again?
Endura block,
Block, which is a stacking block.
dry stacked, and used a stucco kind of material with lots of extra fiber in it to make it strong.
So you kind of stick it together on the surface.
That's right.
Okay, and so there are different versions, and they're all trying to accomplish the same thing, and that is take us back to solid wall construction. And some work better than others. Ken's been happy with his. I personally like this one. I was one of the early guys to try it in the 90s, and it was horrible because they all came with flat sheets and you had to slip the plastic into them and they would blow out and you'd have concrete all over the site. And we ended up having to build plywood walls on each side of it to hold them together to get the pour and then salvage the plywood off. This one, I did a home and we did 18-foot tall walls and we had 0 blowouts. We had no concrete outside of the forms. And so they've come a long, long way in a few years.
So that 18-foot, did you pour that in lifts?
Yes,
Okay.
2 to 3 feet at a time. There's a picture of the home that I'm partially through. I think it's the second or third photo if I can get to it. Yep, it's that one. And up there on the top, it is 18 feet tall to the top. And that is solid concrete all the way up.
Inside all that.
Inside the wall, yes. So the insulation, everything goes all the way up.
You said 6-inch, they also come in 8-inch.
8s, 10s, 12s. If you're going to do a basement and you want to pour the basement and then have your I-joist sitting on top of that, they do make, at least Fox Blocks makes a ledger where it comes out and you have a wider place to set those on. You can cut out and insert your joists into them. You can stick J-bolts into them and pour them in place and then attach your ledger board to it. So there's lots of different ways to do that if you want to go from an 8-inch to a 6-inch. The determination was I didn't have any great load, 6-inch was plenty, and it worked really well for my application to use 6-inch. So there's a few movie theaters that they've done and they use 12-inch because they are 30-foot tall walls, straight, no support anywhere, and they've worked quite well as also.
So the interior finish, do you just use adhesive to put sheetrock to it?
No,
or-
sheetrock screws. Inside. These are spaced every 8-inch on the Fox block. Some other versions vary a little bit, but from here to here is 16, which is your normal framing.
Yeah.
Just inside here, you've got a piece of plastic where it starts Fox block that is that wide. It's a continuous strip. All you gotta do is run your sheetrock screw into there and it holds. So there's no additional inside framing. There's no house wrap required. There's no additional insulation. So the really cool thing is you stack the block, you put the rebar in, you fill it with concrete, you're ready for your outside covering and your inside covering. Okay?
And where did the electrical, all that sort of thing go?
That's really fun. I have an electric chainsaw. And you just cut grooves in it.
Before you,
Before you finish the inside, You lay the wire, the Romex wire on there, and you tap it in, it stays in there, and you go back over it with your spray foam, fill the groove, the wire doesn't move, you haven't lost any insulation value, it'll bubble up a little, you just go back with a handsaw, slice it off, it's nice and smooth, and you don't even know it's there. So it's a really simple system. Okay. You can cut angles, you can do all sorts of stuff, you can cut arches, you can do whatever you need, you can cut windows wherever you want them. This system has what they call window bucks, which are 2-inch flat pieces that lay across the ends that have the same structure in them that you can screw your windows right to. So it's fully insulated all the way around, and they're all hurricane tested, so they don't blow out. And it's a really, really simple system. So that's what I like. If I was going to build again anything, this is the system I would use, whether it's any one of a dozen different companies, depending on which is the price right at the time. We had the new NRC, the nuclear people, come and talk to us a while ago. And they talked about how to survive a nuclear event. Well, and it was all about mass. It was all about weight. This particular product here gives you a 6-inch concrete wall. You have to take care of your windows. My particular home, I have a center in it that is a pantry that is built out of the same material with a 12-inch concrete floor on top. I have a concrete room, a solid concrete room in the middle of the house. So I have an outside concrete wall and inside concrete wall. So in the event of a nuclear event, that's weird, event and event, the concrete's very protective. Okay, so there's things like that. It's really hard to blow over. Why we're not using this in hurricane areas, I don't know. Why we're not using tornado, I don't know. Everyone knows that trailer parks are always in the path of a hurricane. They're always in the path of a tornado. Stick frame houses are right close behind. These homes don't blow away. Okay, so we also talked about some other types of construction. They're doing some interesting stuff that are shotcrete balloons. They'll take a balloon material and they'll make a dome shape out of it. And then they'll lay rebar all over the top of it, tie it, and then they will spray concrete over it, lead hard, and then they'll deflate the balloon. And now you have a full concrete structure that you can cover with dirt or whatever you like. And they're pretty cool. They have lots of different areas in them and hallways and all sorts of things. And they'll put 12 inches of concrete on the top of them, and you have basically a bunker above ground. And you can put windows in them, doors in them, all sorts of stuff. Earth domes. One that I really like, I've got a picture of one in here. The bottom picture, it's the green one. And that particular system is a fiberglass shell that you bolt together. They're made, the pieces are all made in a factory, and they come in on a flatbed truck, and it takes no skill, no skilled labor to bolt those pieces together. You run all your electrical on the outside in conduit and poke it through. You come back and you stick sandbags up the sides and then cover with dirt, plant grass, etc. on top of it. Now you have a sod house, but now you have these nice shiny white walls inside that you can then frame out to whatever you want. These are really cool in some of the less developed areas where you don't have the skilled labor, and in Central America where you have people that are making, $10, $15 a day. They can do this with no extra training, no extra skill, nothing like that, put them together, and you don't need concrete, which they mix in 5-gallon buckets. They don't have ready-mix trucks. They do beautiful, beautiful work. These go up fast. You can build the structure in about a weekend on a 1,000 square foot home. Come back, stack the sandbags, cover it up, you're ready to finish the inside. So this, like I say, you gain that 12 inches, 13, 14, 15, 18 inches of earth over the top. There's your insulation. There's your protection from wind and hurricanes and rain and snow and everything else. And so I think that's a really, really cool addition to those sorts of things.
Have you noticed any off-gassing of the styrofoam inside of your structure?
No, I have not. It smells like a new home. And I mean, it smells like wood. It smells like I framed the inside of it with lumber, and I smell the lumber. I have no smell out of these whatsoever that I can tell. There have been some news stories in other countries where they're saying that they won't finance homes that have any foam in them. And early foam had formaldehyde in it, and that was causing some issues. The later versions of foam, since about 2000 or a little before, have had no ill effects. The other part of it is the roof. That is my roof, with that on top. So I've got R17 with reflective on top. It also has a reflective on the bottom. I've got the OSB. I've got 4 inches of spray foam, which is about an R25, and that's all up on top of the trusses. So then I have an air barrier of the attic, and on the bottom side of the trusses, I'm putting that up. Now I'm reflecting 99% of the heat into the house, 99% of the heat into the attic, into the air barrier. It's going up through 4 inches of insulation, hitting 99% reflective, R17, and 99% reflective out. Effectively, there should be 0 heat loss through the roof. And it will not have a 150-degree attic in the summertime. It should be 65 to 70 degrees inside the attic, which saves cooling costs, it saves heating costs, all that sort of stuff. So those are some things I really like in that. We've got a section later on the second page. We can talk about some of the other things I've done in my home, but let's look at power and lighting and energy. We all know that's one of our major costs, and for power you've got on-grid, which comes with a monthly bill, solar, which comes with a high expense up front, wind, depending on where you live, it can be effective or not, a standby generator, and if you're so lucky to be by a river or stream, that you could have hydropower. Those are really the major sources of energy. If you're looking for heating, natural gas is kind of what we're all used to in this country, this part of the country anyway. East Coast, they're heating oil and trying to get towards natural gas, and a lot of them are going towards propane. This area where you don't have natural gas, they're using propane. A lot of us are using coal or wood, which are still very viable. And passive solar is a really good way to increase the heat capture in a home. Large windows, large overhangs. My particular home has 24-inch eaves, 24-inch overhangs. So I get shade in the summer on the windows, and as the sun drops down in the winter, it comes through the windows and gives me the sunlight, gives me the heat. So it's all in thinking through the design and how you get that. You can also do sunrooms, you can also, all those sorts of things which create that, move it through the house. Those are other ways to gain that. Another method I like on heating and cooling is a ground source heat pump. That was my original plan to do, or a ground source heat pump. There's some diagrams of what they do, but you'll drill a hole into the ground, or you'll cut a trench, and you'll run tubing either in the trench or down about 100 feet back up. You'll pump water or glycol through those loops into the ground, which stays about 65 degrees year-round at 7 feet or deeper. You pull that energy, that either heat or cooling, depending on time of year, from the earth, you run it through a heat exchanger into your home. All you have in heating and cooling costs is the cost of circulating that cool air, and you maintain about 65, 70 degrees in the house. So those are great. The problem with those is the cost of drilling the 100-foot holes or the excavation or having enough ground to do it with. So the simpler, less expensive route is a heat pump. That's the direction I went, which brings us to the HVAC. We skipped the LED lighting, but we all know LED lighting is about 1/4 of the cost, because a 23-watt bulb will produce 100 watts equivalent of an incandescent bulb. Four times the light for the same amount of money, or 1/4 of the cost for the same amount of light. If you add dimmers to those, you don't need full bright light, you can cut it down, and if you go to 60%, it reduces the consumption by about half. So lots and lots of ways, and that can be done in an existing home or a new home. So back to the HVAC. Typical use is forced air, which most of us have in the homes we live in. It can either be powered by gas or electric. Was very inefficient. Now with some of the new technology over the past 25 years or so, they're adding flue gas into it, so you're 90–95% efficient. You don't get the big rush of hot air, you just get the warmer air, and it's more efficient. However, forced air is one of the least efficient ways to heat a space. Get the room full of warm air and all that stuff, kids open the doors, run through the house, where'd all the warm air go? Out. It wasn't there long enough to really heat everything in the house. My personal favorite is radiant heat. There's a picture on one of these of some tubing on a floor. If you run your heat tubing, your radiant tubing in your floor, I prefer concrete because it takes us back to the thermal mass. If you have a wood floor on a second story or over a basement, you can run that either under your wood floor and have reflective tin to reflect it up into the room space. You don't get the thermal mass, but you get the radiant heat. That heats the inside of the building. In a concrete home, in a concrete floor, you're putting all your heating into a slab of concrete. Now that concrete is 65, 70, 75. I hope not any higher, Jane. No warmer than that. But that holds the heat, and it radiates and heats everything in there. Kids open the doors, run through. They didn't change the temperature of the concrete. The concrete is still at the temperature it was. The walls and everything in it is still the temperature it was. You don't lose the heating. So that's why I really like that. Ways to get the heat: you can do a boiler. You can do the heat pump that we talked about. You can do the ground source or solar. You can add solar heating panels, which you can make 160-degree hot water on a cloudy day on your roof. It's tubing running through a glass face. It comes down and it creates hot water and will heat your house, heat your hot water at the sun's expense. So those are some really good ideas. Domestic hot water is your other part of that. With a heat pump, the system that I used has an outside compressor and all of the gear outside. It runs hot water inside to the house, which then goes into the floor, heats the entire floor, the patio and the garage and everything. It goes into a hot water tank, which creates all the domestic hot water that you can use. It goes into an air handler, which heats the air. So as you're bringing air into the house for breathing air and air changes, it changes the temperature on the incoming air to match the heat of the floor. This is all done with one unit. They can be retrofitted to your existing home. You can take out your standard forced air gas unit. You can put in the heat pump outside, run the hot water inside through that. Now you don't need the gas, it's full electric, and it's really simple. So that's one thing I like. There's a big push on mini splits, if you've seen those or heard of those. It's basically an air conditioner that you can decide which side's gonna be hot and which side's gonna be cold. And that's the same theory behind a heat pump. A heat pump, if you're at all familiar with refrigeration or air conditioning in your car, you have a radiator inside and a radiator outside, in the simplest terms. You are taking the heat out of here and moving it over here. And with a heat pump, you have a valve in here that decides, okay, I want the heat here or the heat here. I'm just gonna switch those, and I'm gonna make heat here and cold here, or heat here and cold here. And that is the beauty of it, all in one system. A lot of people doing the radiant heat only have boilers, they can't cool. With a heat pump, I can cool the floor, I can heat the floor. I can cool the air, I can heat the air. And so it's one unit that you have to do all that with. Same with the mini split. Fans. I also like ceiling fans very much. I put them in every bedroom and every large room to circulate the air. One of the things in every home, whether it's new or old, you have air stratification. Heat rises. You put all the heat you want on the floor, where's it gonna go? Up. Okay, so in the summer, you want the fan to blow the air down so you feel the breeze and you feel cooler. In the winter, you want to pull the air up and force it around the walls and bring the warm air down. So you can make the perception of the temperature in the room much different by moving the air in the room. And so you're not heating the top 2 feet where you're living in the bottom 6 feet. You can bring that air back down and you can warm yourself with the ceiling fans. They're not expensive, they're not hard to install, and they're really efficient in that respect. So, vegetation, we can talk a little more about that. That is an integral part, in my opinion, of heating and cooling and all that sort of thing. There's a picture on one of the pages, I think the last page. Yep, bottom of the last page. That's off one of the government websites, and the location of the home is influenced by wind. Wind has a heating or cooling effect on the structure. Sun has a heating effect on the structure. So if you place your vegetation, you use evergreens to block the wind. They're there year round and they will buffer the wind. Use your deciduous trees or your leafy trees on the south and the west side of your home. They grow, they get leaves and all that. You get shade on the home in the summer. Wintertime comes around, all the leaves drop, and now you have sun on the home and you get the free heat. So that would take us to location, which is really simple. Depending on what type of home you're doing, if you want to be on the top of a hill, the bottom of a hill, in a valley, buried inside of a hill, out in the flats, that changes your vegetation, that changes all that sort of stuff, and it changes the orientation of the house. Using windows, using eaves, all that sort of thing changes the amount of heat you get and the amount of heat you reject. So I've touched on it briefly. My goal in everything that I do is blending the old with the new. Going back saying, what did Adobe do? What did sod homes do? What did log homes do? How did they all work? How can we take the best of them? And it's not necessarily technology, in my opinion. We were blessed with lots of great materials here, and we need to go back to those. We need to use the thermal mass. We need to capture as much heat, and be as, I hate the term green, as possible. But that's really the way it is. I don't like utility bills, and when you put in a wood stove, we all put them on a hearth. We all put a wood stove on cement or rock. How many have built rock walls and concrete walls behind them? Reason being, that's thermal mass. You're creating all that heat and it's going into 2x4s. It's not storing any of it. So if you have concrete or rock, it is storing that heat that will radiate all night or as the fire dies. So we'll go on to the next. So we talked about passive solar, ground source heat, vegetation. The older materials, the heavy materials are very, very durable, very secure. Like I said, all the European buildings are still standing for hundreds of years because they're stone, they're masonry, they are built to last. You look how fast our 2x4 homes fall apart. You go back to some of the Amish buildings, some of the post and beam, where they were mortise and tenon, they're still there, but they were oak. You know, they were much larger timbers designed to last, where the 2x4s and 2x6s and, you know, cheap screws just aren't. So let's look at upgrading your existing home. So not everybody's able to build a home. What can we do to upgrade our existing homes? Real simple, weather stripping. Any place that you've got an opening or a closing door, make sure your weather stripping is good. If it's a newer door, they are replaceable with the hollow foam that you can snap, pop in them. If you don't have the newer doors, then you can stick on foam. That works really well. We go back to foam, spray foam. You can seal any of the gaps. Some of the foams will seal up to 2 inches. Hopefully you don't have any holes 2 inches big in your home, but go through the home, feel for drafts, fill any of the leaks, any of those sorts of things. Storm windows are a really good addition if you have older windows. If you haven't been able to upgrade windows and get a double pane or a triple pane, think about doing some sort of additional sealing on the window for the winter. It can be a piece of Lexan, it can be a full piece of glass, it can be as simple as the plastic heat shrink that you put on it, hit it with a hairdryer, and that will seal that, and that will help you out. Window coverings also help a lot. There are various different grades of window coverings. Some are just for pretty, some actually insulate. So if you're trying to get more heat to keep in, use an insulated window covering. We talked about vegetation, same thing. LEDs and dimmers, same thing applies. If you have existing lighting, most existing lighting homes can be changed out to LEDs. It's an upfront cost, but it pays for itself way big time. Appliances. Not all of us can go out and buy new appliances, but that's a huge upgrade. Your furnace, if it's an older 10, 20, 30-year-old furnace, it's probably low efficiency. If you can get a higher efficiency furnace, it will save you in the long run. If you can go to a water furnace or something like that, a heat pump, that's a big savings. Mini splits, flue exchangers. I put on here a picture of a couple of flue heat exchangers. Back on the last page, 2 different types of flue heat exchangers. If you're using a coal burning, wood burning, pellet, natural gas, anything like that, these flue exchangers will go on the flue. They increase the surface area, so you're radiating more heat off the exhaust gas. Some of them have built-in fans, and so you're making more heat out of the same amount of wood. That combined with thermal mass in the walls will capture more heat and save you money there. Solar power, solar heat, we've talked about that. Window coverings, insulation. Anywhere you can add insulation, add insulation. Depending on the age of the home and the construction of the home, you can add foam insulation into an existing home. I've had several homes that were built in the 60s and 70s and even the 80s and 90s that were 2x4 wall, and when you open up a wall, you'll find about this much insulation kind of stuck in a patchwork. Lots of air gaps between it. It is minimal to say the least. In those homes, If it's a brick home, you have a 2x4 or 2x6 wall, you have about 1.5 to 2 inches of air, and then you have the brick. Very easy to come in, and they will drill some small holes down low with a masonry bit and a hole up high, and they will fill that gap with foam. That gets you insulation, and it is now a solid air barrier. You have stopped the air blowing through your outlets, okay? I did one that way. I wanted to go a little further. I had them go all the way in and fill the cavity of 2x4s because I'd seen the minimal amount of patchwork insulation. I gained about 7 inches of insulation at R7 per inch. In an existing home, you couldn't tell it was ever done. So you can do that in either a wood frame home, you can do that in a brick faced home. There's lots of energy credits. It's not incredibly expensive. It's probably $2,500 to do an entire house of about 1,800 square feet. And there's tax credits, there's energy credits. We talked about upgrading windows and doors. If you haven't done it, it's a really good thing to do. You don't need triple panes, you don't need Pella, you don't need the most expensive on the market. You need a competent window company that can tell you the U factor, which is like the R value in insulation. A double pane properly built will give you as much U factor as a triple pane. The benefit to a triple pane is noise. So if you live on a street corner where you have a lot of big diesel trucks or a lot of small import cars or a lot of motorcycles or things like that, we don't have much of that, so double panes are really fine in our rural areas. If you're downtown Salt Lake, Denver, wherever, and have lots of street noise, a triple pane is worth the extra money. In our area, a double pane is adequate, and you can get as high a U factor with a double pane as you can with a triple pane. So, real briefly, I've alluded to my home, which Ken and a couple others have seen. It's ICF, and I love it. It's all the way from the footings, 3 feet underground, all the way to the roof. My particular home, summertime when we were about 110 degrees, it was low 70s inside. Last year in the coldest of cold, when we were about minus 10 or 12, and the highs were 19 or 20 for a few days, it was 50 degrees inside with no heating, no cooling. So all you have to do is put a couple of bodies in there, run a television, cook a loaf of bread. You've now taken the chill off without any trouble at all. Throw a log on the fire. I did high U factor doors and windows. I did 24-inch eaves, which gives you shade. I did the radiant heat in the floor. I've got heat recovery unit, which is as you're changing the air in the house, breathing air. My house is so tight, your ears pop when you close the doors. So you have to bring air into it because you don't want to rebreathe your own exhaust. And so I force air into it, and that also keeps the bugs and the flies and the dust and the dirt out. High efficiency solid fuel fireplace. Many fireplaces are sucking all of the heat out of your home, pushing it up the chimney. New energy codes have changed that to a great degree, but a high efficiency fireplace is going to heat the firebox. Again, thermal mass, heavy steel, heavy fire bricks, and then you're going to have a secondary or tertiary layer, which you then blow air around, peel the heat off that mass, and pump it out. My particular home, I have that. I also have it pumped into the heat recovery unit, so it will go in there and go throughout the rest of the house, and so I can heat the air off the fireplace. I use the heat pump, which heats the floors, the air, the hot water, even the patio in the garage. Roof insulation, I showed you that. I've got a metal roof, which normally brings lots and lots of heat into the house. It never gets past the reflective barrier right underneath it, through the insulation, through the other reflective barrier, or through the 4 inches of foam to heat the attic. Talked about the attic insulation. So I've got this, and there'll be R30 on top of this. So I will have about R75 or R80 insulation in the attic, plus 3 layers of 99% reflective. I've had insulation of people telling me, oh, that's overkill. No, until I reach 0 transference, I can still do better, is my opinion. Ceiling fans in every room, and in my particular home, all my return air are at ceiling level. Once again, heat rises. Wintertime, I want to take the heat off the top. I want to move it through the house, recirculate it, and save the heat. Summertime, the heat rises. I want to take the heat off the top. I want to cool it and bring it through the bottom of the house. Rather than having all your heat registers at the bottom, just my own personal take on it. LED lighting and dimmers throughout the house. I've got a concrete pantry inside the center of the home, which maintains about 60 degrees all the time inside the middle of the home. I didn't have a basement, so I didn't put it in the basement, but it stays, it's not damp. So no humidity, anything like that, where some people are fighting that in root cellars. My particular home, I did a mudroom between the house and the garage, figuring that that would be the main path for coming in and out, and dirty boots, et cetera, et cetera. It also serves as an air barrier vestibule. So as you're opening and closing the door, coming in and out, you have to go through another door in order to get in the main part of the house. So you can control the air in that one room and not change the temperature in the house. I'm going to use the deciduous trees on the south and the west. Wind blows everywhere from every direction in San Pete. Just depends on the time of year and the day. And so, okay, looking at some of the other examples, we've all seen greenhouses, wall peonies, and root cellars. This takes us all back to my favorite, and that is, how was it done a long, long time ago? How were those things energy efficient? The wall peony, you're bringing the heat up from the ground, you're maintaining that, you're bringing it out of the sun, you're using air, normal convection, all those sorts of things, and that can be incorporated into a house. So that is about what I've got. Any questions I can help with? Everyone was quiet except for Ken, and I appreciate that.
Their quietness or my loudness?
Yes.
You didn't put a basement in.
I did not.
Generally, that's the cheapest floor space you can have if you happen to need it. Any reasons you didn't? Do you wish you had?
If you see, my hair is gradually approaching the lighter color. And I've had basements in every home. I've had upstairs in every home. I'm tired of climbing stairs. And I've been blessed to have several careers in my life. One of them was in the real estate business. And one of the favorite things we said there is, why do you have an attic and why do you have a basement? Well, so you can store junk above and below you. It can be sandwiched between your junk. And, you know, again, I was blessed with a very, very large turkey barn, so I can fill that with my junk and not have to be sandwiched between it. We didn't want stairs. It is less expensive. A second story is actually less money than a basement if you're doing stick frame. So you get benefit out of the basement because you do get some of the normal convection, some of the normal cooling from the ground, and it comes through as long as you're dealing with the moisture, as long as you're dealing with the airflow through that space. So that's why I didn't do it. But it can be, but rarely are they finished. Majority of people don't finish them until 2 weeks before sale. That's when I finish my home. Every one I've ever lived in that I've ever built for myself, I've started, I've got mostly done, and then I lived there for a few years, and it was time to sell it. Now it's a mad dash that last 2 weeks to finish the house. Looks really nice, but I didn't get to live in the finished house, somebody else does. So I've learned that I just don't need a basement. I don't see any of us here really in our early 30s or 40s with lots of children. that we wanna chase up and down stairs. And we probably are on the position of trying to clean out and not have quite as many treasures. There's a difference between being rich and broke. Rich means you have a whole bunch of stuff, broke means you don't have any money. And so looking through our homes, I look through mine and says, I don't need a basement full of stuff. And I don't need a huge house either. I think you're in that same position, Ken, where you just don't need 5, 6, 7,000 square feet of home to keep up with the neighbors. The neighbors don't even need that much home. So smaller homes, more energy efficient, put the money into the things that last, that you can't change, has been always my motto. Buy cheap carpet, buy cheap appliances, buy cheap window coverings. Your wife's gonna wanna change those anyway, right? But if you put the money into the insulation, you put the money into the floor, you put the money into the windows, you put all that sort of into the structure, it's gonna be harder to change those things, and you're going to have a much better product in the end, because every few years you wanna change the colors anyway. So that's it, unless anybody's got anything else.
Thank you.
That's great.
You're welcome, thank you.